Oh, why did the coach go back to the bank to get his quarterback? Or Adam's Catholic because they have mass. Oh, we already read that one. Okay. I suppose that's an okay joke. The second one. I don't know about the first one. Too many quarterback jokes. Well, all right, so if you read chapter 3, right, they talk about, of course, the if statement, which we talked about in class. They talked about the else. So we're going to use those most of the time. If you get into the, let's see, it starts at chapter 3.9, they talk about the switch statement. So last time, if you remember, when we had our program, let me get IntelliJ here. Right, we had these options of, right, these different items where we had to sort of pick. We had to decide, okay, if it's greater than or equal to 14 and it's less than 16. We also had this, maybe this is the more applicable one, right? Okay, we're going to check to see, ignoring case, if they type yes or y or yeah, right, to answer this question that we had. And that's just, first of all, it's hard to read, and it's probably not very straightforward. So the switch statement, I'll make another class here. Allows us to make this a little bit more readable for if we wanted to read in some values. So let me go grab the code that from last time. Just the code I want. And I just can't take IntelliJ. It's going to kill me. Okay, so here's our code from last time. Can you guys read this font in the back? Callie, can you read it? Yes, okay. All right, so another way to do this is to use our switch statements. So switch statements in recent versions of Java have had the ability to switch on strings, which is like a huge benefit. You guys don't know any different, but for me, it's an awesome thing. So, so basically what I want to do here is, well, when we ask the question, are you blind, right, we get some line. And what we can do with that is we can just turn that into lowercase letters so we don't have to worry about the uppercase, right? So just by default, we're going to say, whatever this is, make the case so it's all lowercase. And so the are you blind will only hold strings that have all lowercase letters. And then we can use the switch on are you blind. Now, right, switch just like when we do the if, right? So switch, you have to have the curly brackets, right? There's no way around it with the switch. And so the curly brackets mean that, okay, I'm going to look at the are you blind, and then I'm going to give a bunch of cases or instances where I want to do something special, right? So we have examples of yes, why, and yeah. So the syntax is case, and then we put the thing that we want to match. So yes, and you got to put a colon. Now, in order to tell it like where to stop looking at these cases, we have to use a special keyword. Does anybody remember what that keyword is? Break. You're correct. Front row on top of it. Does it make you smarter if you sit in the front row, or it just, I don't know. I always sat in the front row, but that's because I can't hear. So, you know, different reasons for different people. All right, so we can say the break statement to say stop processing. But we can give a bunch of cases here. So we can say case Y. And this is a colon. Case, yeah. Right? Of course. Now, I don't know that anybody would want to type that, but. Right? So these are all things that we want to handle in one at one time. Right? We're saying all of these are equivalent in this example. Now, typically you might say something like, for example, if you want to ask somebody if they want to do the calculation for lightsaber using lead or using steel, you might say, enter a 1 if you want to do lead, and enter a 2 if you want to do steel, and enter a 3 if you want to do kryptonite, or something like that. Right? So we can go through all of the different ones, and we can give them an option, and then we can switch on that. So that way we can just very easily see what we're doing. So in those, after each one of those, you would have a break, because each one of those is its own special instance. And then we can put a piece of code after the case, but before the break, it will get executed when any of these match. Right? So if any of these match, it'll execute this code right here before the break. So we might say something like this. We might say that. But I'm going to try and be smarter about this, because right now we're doing this if here, and then we're having another one that says, oh yeah, you're not allowed to drive down here either, right? So we have these two cases where, okay, you're not allowed to drive. Now, we do have a special type that can only hold things that are true and false. Does anybody know what that type is? Boolean, right? It's named for the mathematician, I want to say Albert, but that's probably wrong. Edward Boole. Charles? God, I'm drawing a blank on his. There's a mathematician. George! Oh, so close. Yeah, not really close. Right? So George Boole, he made this language where you could have something is either yes or no. They call them truth values. So we have a type named after, right, a famous guy. So if you guys invent something really awesome, right, they might name something after you. Java is named after a island, the island of Java, right? So which it's actually named after coffee, which is named after the island, right? Java, Java coffee. Anyway, all right. So we have this type called bool that says we can hold something that is a yes or something that is a no, or something that is a true and something that is a false, right? So those are the values that we give to it. So we could define a variable up here. Let's pick a name. What's a good name? You guys are better at naming things than I am. Anybody have a name? What? Henry? Okay, Henry. Not very descriptive, but it's open. Henry. I'll change it later. Okay, so Henry is going to be representing Are We Blind? Okay, maybe Henry's not. We'll just... Are you blind, right? And remember, right, the case of these is different, right? So they're different variables. One is a string, the other one is a Boolean. So we might say, are you blind is, we'll say, true. We don't know. But down here we can actually set this, right? So we can say, if they entered any of these things in match, we can say the actual are you blind is actually true, right? And then there are two options for what we can do next. We can list out the things that we think mean that they are not blind, right? And that they thus can drive. So we could pick a bunch of cases, right? Case no, right? Case N. Right, remember these are all lowercase because we lowercased it. Case I am a dog, right? And clearly, I don't know, right? We can pick all kinds of things. Right? They can type any of these, and that means that they're not blind, right? And so, what would we do inside of this? What would we set? Front row, you're not allowed to talk. You get banned. You answered too many questions already.
Are you blind equals false?
Are you blind? Perfect, right? Are you blind equals. Do we need anything else? And the break. Okay. All right, so that means that, yeah, we're going to stop processing. Now, there is another case that is built in, and it's called default. I think it's indented, yeah. So default you always put at the end. That means if it didn't match any of these things, right, then it's going to go to the default case, right? So the case of, I don't know what you typed, right? Please try again. So we could do that. We could print something out. Right? And we can actually, if we're like, well, they didn't type something I recognize, we can just exit. I'll put -1. -1 means that something bad happened. If you exit with 0, that means your program went in okay and everything was fine. But exit -1 means like bad stuff happened, right? Somebody typed something terrible. My age, 21. Are you blind? Eh? I'm 21, so I can't have alcohol, but I answered badly, right? So maybe I move the order of those around so that it's like, yeah, you typed in something bad. Because is not a legitimate thing. But if I run it again and I am 15 and yes, are you blind? Yes. Right, so I can't drive, right? Because we set that Boolean when we matched it, right? When we matched yes, right, all lowercase, right, because we lowercased it. And then we went on. So does this make sense? Any questions on this? Yes?
I was wondering what are system.exit?
So system.exit means you're going to quit the program. The -1 means that there was an error, right? And so if you ran this, let me see when I run it. It might show it here. It doesn't show it in this, but sometimes when you run a program, it might say that it like quit with an error. So when I run lots of programs, they have an error message that's returned, so that's what that -1 means. But you don't have to do this. I was just doing it so that it just quit, right? It just quits right at that point in my program. All right, so we did set the Boolean, but we'd like to maybe use this, right? So it set our variable, but we weren't actually using it. So in our if statement, what could we say here? Instead of all that, if are you blind equals true. Right, and remember, why do we need double equals? Anybody remember? What's single equals? If I just use one equals, what is that? We're assigning a variable, right? And when we use double equals, we're checking for equality. And remember, so what this is going to do, we call it evaluating, right? We have an expression. An expression is a bunch of conditions that are put together, right? Last time we had a bunch of ors in between, right? The 2 bars. And so what it's going to do is it's going to evaluate this expression, and it's going to say, is that expression true? Now, Right? Andrew was right. We can say this, but there's also a shortcut where we can just say, if are you blind, right? This are you blind is a Boolean, so it ends up evaluating to either true or to false. So a shortcut is to write it this way, right? And that says if are you blind, right, by default means it is true, right? If it is true, then it executes that line. So either way is technically correct, right? I a lot of times will teach this because when you read it, it makes a lot, like, you just get it, right? If are you blind is equal to true, right? And then if we decide to change our mind, we can say, if are you blind is equal to false, right? Then we would do something, right? So it's a little bit easier to do it. Now, if we do the first one, does anybody know what the negate is in programming language to do the opposite of? Exclamation point, right? So we call it bang, right? So if not are you blind would be the opposite of if it's true. So if it's false. But we'll go with this one here. All right, so if that's true, then we're going to print that off. Otherwise, right, we go through the check about what are your ages inside of there. Now, technically, I could theoretically collapse this all into one if statement. So let's see if we can do this, right? So we're going to take out this part here. And what I want is I only want this to get executed down here if neither one of these got executed. So what is the only time I'm going to check if age is greater than 14 and age is greater than 16? If I'm relating to are you blind? Okay, so if this is true and are you blind is equal to false, right? So that means that all of these conditions have to be true, right? So this and this. So if are you blind is true, right, this one's not going to get executed no matter what. All right, we'll come down here. So the second one, what do I also want to check? Same thing, right? So then down here, there are two ways that I can get here. I can have not matched any one of these first conditions, right? The age requirements. Or it's the case that are you blind is true, and then thus I skip this one, I come down here. So the benefit of writing it this way is I only have one statement here that's printing off when I'm not allowed to drive, as opposed to two, right? So it might be a little bit harder to read, but logically it makes sense, right? Are you blind will force it to go to this third one, or the fact that you're too young will force it to go to this one. So it should run the same. So if I'm 15, right, I can have a learner's permit. If I'm 15, all right, can't drive. Let's check another case. If I'm 5, well, I am not old enough. I am allowed to drink alcohol, but I'm not allowed to drink, right? Again, this is nothing against blind people. These are just like laws, right? It's just not, unless you have like a self-driving vehicle like Tesla. Okay, so right, hopefully we saw that the switch can maybe make things a little bit more readable, right? And that's kind of the benefit of using the switch when you're designing a system. Plus, it gives us sort of the default, right? Which allows us to say, yeah, I didn't think of everything, right? But here's something to do. If you think about, if any of you use Google, right, and you say just gibberish to it, it'll be like, okay, I'm just going to, the Google Assistant, right? I'm just going to Google that for you, and we'll just let you go, because I don't know what you said, right? I'm pretty sure if I said gobbledygook to it, well, maybe I can try. Let's see. Come on. Okay, Google. What should I ask it? Gabaloo. It figured out World War I era and Googled it for me, right? So I said garbage to it, right? And it like, I think you said this, and I'm gonna look it up for you because I don't have an answer for it. But if I ask it, how many feet are in a mile?
1 mile equals 5,280 feet.
Right, so it'll tell me an answer, right? Because it understood what I said. So, right, that's kind of the same notion of when we're talking about a default. All right, any questions on if statements, decisions?
Can you have a system exit where if you didn't get what you wanted, it re-loops to the top?
Okay, so the question is, can you have a system exit where it loops to the top? So, no, right? The system exit won't solve that problem, but we can make it so that they have to enter something that is valid. Now, let me think how we want to do this. So we basically, okay, we won't talk about that yet. I think loops is probably the next chapter. So we can talk about that then. But basically what we're going to talk about is how do we do something repeatedly, right? And so what we're going to want to do is we're going to want to ask a question, right? We're going to get an input, and then we're going to say, is this valid? Which is the term that I usually use, right? So I actually make a variable called isValid, and I'll say, while it's not valid, let's keep doing this, right? So then we'll break out of it when it is valid. So we'll go over that, and it's kind of a construct, but it'll be in the next chapter. So that's a good question. Other questions? No? No questions? I guess I just talked too fast. Let's see if my tab is updated. So this is how I roll, right? Dummies.com. Oh, perfect. Okay, so I thought it'd be fun to maybe do some physics stuff just because physics is more boring than doing a bunch of math that doesn't matter. Right, so physics is the application of math, right, to science, so that we can figure out and solve problems. Like here they're talking about figuring out how fast somebody is going, or the question I always have is if I have this marker, right, and I drop it. Like, okay, how long did it take to go that far? Well, I don't know. But there's math, right? There's physics. And physics can tell me if I drop it from 1 meter and I start it at 0 meters per second and I drop it, well, how fast is it going when it hits the ground? Well, physics tells me how far we can figure that out. Or if I drop it and I wait 1 second, 1/1000, how far has it gone? Right, so that's kind of the cool stuff about physics. I like physics. I think it's fun, but I'd like to program it. So here we got a couple formulas. So the first one is s, which is distance, is equal to half of the acceleration times the time squared. So we're just going to do that, right? It's a formula. We know what acceleration is, right? How many meters per second is gravity? 9.8 meters per second squared, right? So that's the constant acceleration, and then we can figure out, okay, well, if I accelerate for 1 second, how far did I go? 2 seconds, how far did I go? 3 seconds, how far did I go? Right, so I started a basic program that's going to do this, right? So we should probably, right at the top we have our scanner S. One thing I forgot to mention when we talked about it, I think the book probably talks about it, is when you're done with the scanner, you'll want to close it, but that gets rid of that warning, right? So it stops saying, totally freaking out. All right, so maybe I should print off a prompt because, that would be good. User interfaces are great. I'll print. And then the 1/2, right? So I rewrote that as 0.5. Acceleration is on Earth, 9.8 meters per second And the time, right? So time squared. So if we look at the physics for dummies, or right, is, well, so the first one is the VI, which is the initial velocity. So if you drop something, right, it's not moving when I let go, right? Provided I sort of drop it properly. And then you drop it and you see, right, that term goes away because it doesn't matter. And then we just left with 1/2 AT squared, where A is acceleration and T is time. So it should give us the right number. So let's say we drop something for 1 second, right? So I don't think I have 4.9 meters. Gosh. Let's see. Let's try a different time. Oh, and then I type something bad, right? And my program's like, I'm freaking out. Okay, how could I fix that? Anybody who's not in the front row, want to take a guess?
Change your time to a double.
Change my time to a double. Oh, it's still called time. Man, I'm failing hard today. I was up too late last night. So is that right? Is that gonna fix it? No, hold on. In the back. I need to do S dot next double, right? That's actually where it crashed. So now if I put in, okay, 0.04 meters. Well, that's not. Okay, so it's going to take, I want to get to 1, 0.2, 0.19, 0.4. If only there was a way I could automate this. Oh, jeez. I got to write a program. So it probably takes less than, what, half a second, right, for me to drop this from a, let's see, 1 meter is probably about, what, that high, 3 feet? So if I only had, like, the ability to time it, I could figure out, okay, that's maybe a half a second, right? So I did one of them, but they list, there's a bunch of different formulas. So that's solving for distance, right? And they have different formulas that tell you, well, if I'm solving for time, right, that might be something different. So if we're in math, right, we can like reorder these terms. So I was thinking, well, man, what if we wanted to figure out, we knew the distance was 1, right? We're dropping it from 1 meter. Right? So I could rearrange my terms and figure out what the time is. Right? So I've got S is equal to 1/2 AT squared. Right? So if we multiply by 2, right, now I got 2S. Divide by acceleration. Right, so now I got t squared, and I take the square root of that whole thing. Right? And that should give me what the time is to go 1 meter. Right? So let's see if I can do this. If we can do this. We are a team. You guys don't sound very excited about it, but we're a team. No? All right, we're a team. Got to get you guys to join in. Acceleration 2. All right, so we don't want to enter the time. No, this is acceleration. Acceleration 2. We want to enter the distance, right? And we'll read that. Okay. So my distance I read in, and then my formula I figured out was, so now I'm not setting time distance, I'm setting time. Right? So time is equal to 2 times distance right? Divided by 9.8, which is our acceleration. And then square root. Does anybody know how to do square root?
You can either use the math API or you can multiply it by 1/2. Or, yes.
Well, I can't multiply.
To the 1/2 power.
To the 1/2 power, I could do that, but we'll go ahead and use the math dot square root. Right, so we got a function that'll do that. There's a function for that. All right, so that will give us our time, and so when we print it off, we're going to say the time to fall is, and then we give it time. So with the I didn't change my prop. Let's change my prop. Oh, it is right. Okay. Let's do this. Distance, 1 meter. Hey, look at that. I figured it out. In 0.45 seconds, right? So, me dropping this marker, that's like half a second. If I wanted to figure out 2 meters, .6 seconds. So, 2 meters is probably taller than me because I'm only 6 foot. So. Right, that's 0.6 seconds. 3 meters. Let's see. 0.78. So then I have to like get up here. Let's see. 3 meters. That's almost a second. Right? So I mean that's cool, right? We can do those calculations, and we're being lazy and naive and like completely ignoring the fact that there's wind resistance, right? That sort of slows it down. I think, let's see if I can find it. Dropping, drop. Let's see if I can, there's a really great, here we go. Wonder if it'll play sound or if I just got to turn it all the way up. And they go through the whole thing.
This is NASA's Space Power Facility in Cleveland, Ohio, and it is the world's biggest vacuum chamber. It's used to test spacecraft in the conditions of outer space, and it does that by pumping out the 30 tons of air in this chamber until there are about 2 grams left.
Oh. Frick, now I gotta go get my seat. Huge.
Let's see. All right. I gotta turn the volume up.
Part of its history. It was built in the 1960s as a nuclear test facility to test nuclear propulsion systems, and that meant that they built it out of aluminium to make the radiation easier to deal with. Aluminium is not the best thing, the strongest material to build a vacuum chamber out of. So they built an outer concrete skin, which is part radiation shielding and part an external pressure vessel, so that this thing can take the force that's present on the outside when it's pumped out to the conditions of outer space. Galileo's experiment was simple. He took a heavy object and a light one and dropped them at the same time to see which fell fastest.
See, lazy programmers, ignore that. Ah,
Now in this case, the feathers fell to the ground at a slower rate than the bowling ball because of air resistance. So in order to see the true nature of gravity, we have to remove the air.
Can you imagine how much work it took to build? Design it.
It takes 3 hours to pump out the 800,000 cubic feet of air from the chamber.
We dropped 2 millitor in the last 30 minutes.
But once it's complete, there's a near perfect vacuum inside.
6104 manual, 10% open. Station 1, go for drop. PCB 30-1, pressure set point at 240 psi. We are go for drop. 10, 9, 8, 7, 6, 5, 4. Cameras on. 2, 1. Release.
I wonder if they're going to try.
Look at that. They came down exactly the same. Wow. Look. How they hit right there.
Exactly.
So there you go. In space or a vacuum like that, our equations are completely 100% correct. All right, so I think that that's more fun than me telling you that, you know, most apps are like asking you, what is your username? What is your password? Right, doing that. Okay, that's stuff that you all get to do, but physics is always fun because it allows us to figure stuff out. So, next time we'll add some ifs in there, and we'll talk about figuring out, okay, when maybe is something traveling faster than 60 miles an hour, right? If you drop it, is it traveling faster than the speed of sound, right? In a vacuum, okay, where there's no sound. Okay, but we'll do all of that, and that should be fun. And then on Friday, so I decided that also what might be fun is for us to talk about some current events. So I think on Fridays I'm going to try and talk about what are things that are happening in technology that are interesting, you guys may or may not have seen, and so we'll discuss some articles that I found that I thought would be pertinent and interesting to you guys. So, all right. Look, I'm going to post the homework today. It will be due next Wednesday, so make sure you are paying attention to that. and we'll talk about it also on Friday. So those are the things we'll talk about.